Hi guys, so today we're going to be talking about the Pythagorean theorem. I'm sure you guys have seen this before, but I just want to refresh your memory as we are going to be using it in geometry next year a lot. Okay, so a right triangle is a triangle like this one that has at least one right angle, and right angles are marked by drawing this little square in the corner. Okay, in the right triangle, the sides have specific names. Okay, there are always two legs that are adjacent to the right angle. So basically, the sides that are right next to the right angle are called legs, and the side that is directly across from the right angle is called the hypotenuse. The hypotenuse is always the longest side in the right triangle. So if you have the lengths of the sides, the longest one is always the hypotenuse. Okay, so the Pythagorean theorem states that the sum of the squares of the legs, so a squared plus b squared, equals to c squared. Okay, and we will prove that next year. But for now, you guys going to use this relationship to find the missing length of a side in the right triangle. Okay, so the most important part is, in problem like these, is to always determine which side is the hypotenuse. Because it doesn't matter which one is A or B, but it matters which one is the C. So A and B can be swapped. Like for example, in this triangle, we have two sides that are adjacent to right angles. These are going to be our A and B, and we can make 3 equal to A, or we can make 4 equal to A. Okay, and say, oh, swap them around. But C is always the side that is the longest and is directly across from the right angle. Okay, so in this case, this X represents C. So to solve these problems, we're always going to start with the formula for the the Pythagorean theorem formula. So we are going to use, hold on a second, I'm going to write a squared plus b squared equals c squared. And then we're going to substitute what we know. So a and b, that's 3 and 4. It doesn't matter what the order is. So I'm going to write 3 squared plus 4 squared. C is the side we don't know, so I'm going to write x squared. Okay, and then we're going to simplify. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Okay, and remember to get rid of the second square, we're going to square root both sides. So that means that I'm going to take square root of both sides. So that gives us that 5 is equal to x, or to make it even nicer, x is equal to 5. Okay, so we found our first triangle. Let's look at the second triangle. So if you look at this second triangle, okay, remember the two sides next to the right angle are the legs. So in this case, we are missing a leg. Okay, this other side, this one right here, is the hypotenuse because it's across from the right angle. So again, we're going to start with writing the formula for the Pythagorean theorem first. So a squared plus b squared equals c squared. Okay, we know the hypotenuse is 10. Okay, and we know one of the legs is 5. So we're looking for the other leg. Okay, so again, we're going to solve it. So a squared plus 25, because 5 squared is 25, is equal to 800. I'm going to subtract 25 from both sides. And that gives us that a squared is equal to 75. And again, to get rid of the second power, we're going to square root both sides. I'm sorry, I said 75, but I wrote 72, so I'm going to fix that. Okay, so this was supposed to be 72. 75, sorry. So we're square rooting both sides, and remember, we have to simplify radical. We can't just leave it as square root of 75 because this radical can be rewritten as square root of 25 times square root of 3. 25 is a perfect square, so the length of A is 5 square roots of 3, and we're going to leave it like this. We're going to leave it in simplest radical form because that's the exact answer. Okay, so I hope this helps you guys solve your practice problems, and I'll see you tomorrow.